This is the Object-Oriented Principles activity. I have the C# README open along with Visual Studio. I'm not going to do this in all 4 languages. I'll just pick one, so I'm going to use C# for today. The concepts about which I'm going to speak are applicable to all 4 programming languages. So everything I'm going to do here will apply to the other 3 languages as well, Python, Java, and JavaScript. I'll just simply use C# to go over these concepts. I do recommend that before I go too much further, pause the video and do research if you haven't. Look into the definitions of abstraction, encapsulation, inheritance, and polymorphism. Make sure you read through and see what's going on. When you're done, come back and we'll finish up on this video. So talking through these concepts, abstraction is probably the one that most websites and even some of the AI are going to get wrong. They're going to confuse some of the concepts in abstraction with encapsulation. Not always, but fairly commonly. Abstraction is really a concept in human communication and thought processes. Abstraction is the process of using a term or a name to mean something generally. So for example, I'm sitting in a chair right now. You know what a chair is. A chair, the word chair, is an abstraction for every single chair in which we might sit. So chair, as a category of things, is an abstraction, with the specific chair in which I'm sitting being an instance of that abstraction. So that's the concept of abstractions. In the programming world, abstractions are basically classes. Functions oftentimes can be considered abstractions. Sometimes objects, because it has a name, especially variables, that can be an abstraction. So it's a name or term that means something to other people. That's the idea of an abstraction. So a category of things, we're going to abstract it by creating a name and then using that. We use abstractions all the time. In fact, every word we use in communication is an abstraction by definition. So this is all an abstraction is. It's basically a name that applies to a concept. Encapsulation is the idea that an abstraction, and so this is very tied together, an abstraction has all of its information and behavior contained within it. So a good abstraction is well encapsulated by hiding data and exposing behavior. This is the concept of encapsulation. We'll get to this in a little bit. Inheritance is the idea that some other type inherits behavior or information from a different type. The classic example, and I'll use this as part of the code as we get into this, is shapes and circles and squares and rectangles. So a rectangle, a square, and a circle are all shapes. Right? A shape is a more abstract term for what those things are. That means that shape is, since it's more abstract, we would consider it a superclass or a base class of circle, square, and rectangle, or triangle. So these specific shapes would have these specific abstractions, so circle, triangle, rectangle. These are going to inherit from shape. In other words, they get the behavior of shape, and then they're able to do other things and have more specific implementations. So shape, for example, I don't know which shape it is unless I know more information. So that's the idea of inheritance. Polymorphism, this one's a little bit trickier. We'll get into this when we get into the example, but it ties very much with inheritance. So these 4 concepts build on each other. It starts with abstraction, encapsulation adds on to abstraction, then inheritance adds on to encapsulation, because you can't really use inheritance without having good encapsulation, and then finally we have polymorphism. So let's look at some examples, talk through what these things might be doing. So let me open up program.cs here. We've got our to-do here where we can decide how we want to break some of these. So let's talk through some of these things here real quick. So let's talk about abstraction first. How can we break abstraction? So let's think about shape for a moment. So I'll create a class called shape. So here's my shape class. And my shape class, and I won't necessarily have code here, although I certainly could. My shape class, what I want to do is I want to figure out how to break encapsulation, or break abstraction. So breaking abstraction really just means that this name doesn't make a lot of sense. For example, if I had a function in shape called, let's see, decimal calculate payroll, this breaks abstraction. Why on earth would I be calculating payroll for a shape? Those don't go together. Now, this is arguably part of payroll or part of encapsulation, but I would suggest that if this is the main functionality we're trying to expose, calculate payroll, then it's on the wrong abstraction. Shape is not a good abstraction. Another example might be if I have a class called my class. My class is a horrible abstraction because I don't know what my class is. That means nothing to me. While it's a fine example that we might see sometimes in programming examples, in the real world, my class is not a meaningful word. No one is going to know what a my class is. So these are examples where we might break abstraction. Let's look on encapsulation now. How can we break encapsulation? Well, let's consider for a moment that I might have a function that returns a double that would be calculate area. that seems like a function that might make sense on shape. And because it's for shape, calculate area seems like it's well encapsulated. However, let's say, and this is actually a fairly common practice, I'll create a shape service class. And the shape service class has double calculate area given a shape. So now this shape service, this violates encapsulation. Why? Well, the reason is calculate area takes a shape, and logically it makes more sense that the shape should be able to calculate its own area. Why would we delegate out the calculate area to a different class called shape service? Again, this is actually a fairly common pattern, but it violates encapsulation. It's not a good pattern, even though it's common. So this is an example where we can violate encapsulation. That doesn't make sense. So we've now separated the behavior that really should belong to shape away from the shape class. It's in a separate class called shape service. So again, this violates encapsulation. So there's our example there. Inheritance. So let's talk about how we might violate inheritance. So we've got shape. Let's also create another class called dog, and let's say it derives from shape. This does not make sense, right? Now I can do this. There's nothing that prevents me from doing this, but this violates violates the principle of inheritance, because why would a dog inherit from shape? How on earth does that make sense? Unless I'm talking about silhouettes, but I'm not, right? So if I had, for example, a method called bark on dog, now I definitely know this is not just some sort of stencil or outline or silhouette or something like that. This is a dog that can actually make a noise, it can probably eat, do other things. That in no way should derive from shape. So this is a violation of inheritance. So now let's look at polymorphism, and we're going to combine that with good inheritance now. So polymorphism, let's create a couple of these other classes. So we'll create a class circle. This will derive from shape. We'll create a class triangle. This will derive from shape. And we'll create a class rectangle. This will also derive from shape. Now this makes sense, right? These are good inheritances. A circle is a shape. We think about that naturally. So this is good inheritance. Polymorphism applies to inheritance. And the idea is that we can define behavior in the base class in shape, and we can change that or override that behavior. So let's say now I wanted to create some method called calculate area on shape. I'm going to run into a problem because I need to know what kind of shape I am. Am I a circle, in which case it's pi times the radius squared? Is it a triangle, in which case it's base times height divided by 2? Is it a rectangle, in which case it's the base times the height? Is it a pentagon? Is it a rhombus? What kind of shape is it? Based on that, then I might know. But the problem is in shape, since it's the base class, it doesn't know about the derived classes. The derived classes know about shape. Therefore, shape doesn't really make sense to have this functionality. So it sure would be nice to say, all right, I have this function here, but I'm going to let circle, triangle, and rectangle specify that. We use polymorphism to do that. The way we generally do that in most languages is I'm going to turn this class into an abstract class, and I'm going to turn this method into an abstract method and get rid of the parentheses or the curly braces. What this means is shape, it's abstract, which means it has at least one abstract member. While it's not a hard requirement, that's a good enough requirement for now. So think of an abstract class. These go together. An abstract class is a class that has at least one abstract member. In this case, our abstract member is the method calculate area. So we use the abstract keyword here in C# to denote that it's abstract. And other languages use different terminology, but the same concept. The method here is calculate area, and I do not have curly braces. So I remove the curly braces and I simply do a semicolon. Again, each language may have slightly different syntax, but the idea is this is an abstract method. This is a promise that there will be a method. Now you'll notice that when I do this, I get red squiggles under these other classes in C#. The reason for that is it knows that I've made a promise for this method and I have not kept my promise. So let's do one of these really fast. I can show potential fixes, and it says, hey, you need to implement the abstract base class. So let me go ahead and click on that, and you'll notice it overrides calculate area. Same method. We use the override keyword to say it was abstract. Now I'm overriding what was there, and I'm giving it actual behavior. And the actual behavior will have curly braces. Now that I have this, I can implement polymorphism correctly. So this is going to be return pi 3.1415927 times this dot radius. And where's my, there we go, squared. So there's my code. Now the problem is I don't have a radius, so let me go ahead and create a radius. And I'll just do this as a class. So this is radius public double radius get. It's trying to help me and it keeps messing things up on me. All right, so we've got a constructor for radius that takes the radius. We pull the radius in. We are going to square this out. What do we have? Double an int. Oh, gotcha. Wait up. All right, we'll do math.pow. There we go. So math.power, we're going to take the base and square it. So we've got radius squared times the times pi, an estimate for pi. This is going to be the area. Now for triangle, it's going to look a little bit different. So in order to create a triangle, we will need the base and the height. So we're going to hold on to those, and base is a key word. Base length, height length, dot base length equals base length. This dot height length equals height length. And now we can override calculate area. And let's return this times base times this times height divided by 2. And I have a spelling mistake. There we go. All right, so there's triangle. And then finally rectangle would just be base times height. So I'll copy a lot of this out. Change that, get rid of the divide by 2. Now I've implemented a rectangle. So now I have good polymorphism. I've defined a method called calculate area as a promise, as an abstract method. That is a contract that says this method will be implemented in the derived types. And we can see that I override that in each of these other methods, or these other classes, to actually implement. So polymorphism, poly meaning many, morphism meaning changing. So we define something that can have many implementations. It can change and turn into different implementations as we need it to. So this is the idea of polymorphism. So we could break polymorphism by not making this abstract and putting all the logic here inside. So for example, if I had double calculate area in a silly way, what I could do is I could do something like if this dot get type is type of circle, then I could return this out. Now the problem is I don't have access to the radius because radius is defined in the circle itself. There is a way to get around that, so I could simply cast this out as a circle since I know it is a circle. And now I can get the radius. Now I can say else if this dot get type is type of triangle, I'll return this, dot base length times this dot height length divided by 2. And then one more, I can do rectangle. And if it's anything else, if it's not one of those, I can just throw a not supported. We don't support that. So now I have broken polymorphism. What I've done is in one method, I basically detected the types. Now you can do this in some languages it's much harder to do what we're doing here, which is why polymorphism makes a lot of sense. So now we've got all of the different implementations here. We are, like I said, violating polymorphism when we do this. So this is not a good way to do things where we're doing type checking. We're saying if the type is this type, if the type is that type, if the type is this type, then we do something else. Anytime you see code similar to that, we are violating polymorphism. We should look at inheritance because implicitly we're using polymorphism. We're just doing it in the wrong way. So this is an example of violating polymorphism. That's basically what I wanted to go through. Hopefully that all makes sense. Definitely ask questions. These are pretty complex topics. They go really, really deep, but I wanted to give you at least a base understanding of what these 4 principles are in object-oriented programming. These topics, abstraction, encapsulation, inheritance, polymorphism, these are favorite interview questions. So it's really good to make sure you brush up on this, make sure you understand this. Definitely ask questions, keep exploring this, but I hope that was helpful.